All right, let's see if I am live. YouTube is not coming. There we go. YouTube is slow tonight. And then on Twitch. Yes, everything's working. All right. So, like I said in the tweet and in the title, and like I tweeted earlier today, um, last night ran into some problems with the notebooks on Microsoft Learn. Um, and so I'm going to switch paths and do the AZ-204. The AZ-204 exam is Azure Developer Certification, and it's in the middle of a tornado watch. So I'm up waiting for. I should probably have my radar up on another screen. So if I have to leave suddenly, that's why. Um, let's see here. What direction is that moving? Yeah, there's a line coming this way. There are no tornado watches near me. There's one down here in looks like Louisiana. I think that's Louis. I think that's right, the Louisiana Mississippi border. But other than that, I'm gonna try to focus on this. Let me get my let me see here on StreamYard up there. And get my okay, now one thing that I'm gonna need to do here is well, we'll get to that later. I don't have .NET installed on this VM. So let's see here, .NET Linux install. Install .NET on Linux distributions. Let's see here. All right. You can download the script. Let's copy this link here. And we'll download the script. Okay, there it is. All right, so we'll copy this here. And if I want to install the SDK. So this is doing the, oh yeah, it says here this is the latest LTS version. But, which is .NET 6 to install the latest release, which may not be version latest, which is what I did. Okay, let's go ahead and restart and do .NET list SDKs. Okay. Why? I don't know why that didn't work. This used to not be so. Okay, here, this is what I want, package manager instructions. Install on Linux. Packages, here's what I really want, I think. Okay, so for 2204, install the SDK here. I think install .NET SDK 6. .NET 7 is not included. Well, I don't think I'm going to do anything that's going to need .NET 7. If I do, I'll install it. And then I won't need the runtime. Oh, and this is what you could use to get .NET 7. But now, at any rate, if I do .NET list SDKs, there we go. I've got .NET 6. Okay, now I can go over here and get my C# extension, which will give me the tooling eventually. Because I'm pretty sure that I'm going to need this at some point. Okay. All right, so now let's go back to and let's start off at the beginning with create Azure App Service web apps. And there are what? 4 modules in here. Okay, so the introduction. Your company is considering moving their web apps to the cloud and has asked you to evaluate Azure App Service. After completing this module, you'll be able to describe Azure App Service key components and value, explain how Azure App Service manages authentication and authorization, identify methods to control inbound and outbound traffic to your web app, and deploy an app to app service using Azure CLI commands. All right, so examine the Azure App Service. Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. You can develop in your favorite programming language, be it .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. Those are not in alphabetical order. Why did they put Python last? I understand why they put .NET first, okay? But why do they put Python last when Ruby clearly comes after Python? But at any rate, applications run and scale with ease both on Windows and Linux-based environments. Baked into Azure App Service is the ability to scale up, down, or scale out in. Depending on the usage of the web app, you can scale the resources of the underlying machine that is hosting your web app up, down. Resources include the number of cores or the amount of RAM available. Scaling out in is the ability to increase or decrease the number of machine instances that are running your web app. Okay. The Azure portal provides out-of-the-box continuous integration and deployment with Azure DevOps, GitHub, Bitbucket, FTP, or a local Git repository on your development machine. Connect your web app with any of the above sources, and App Service will do the rest for you by auto-syncing code and any future changes on the code into the web app. When you deploy your web app on Linux, mobile backend, or API app to the App Service, you can use a separate deployment slot instead of the default production slot when you're running in the standard, premium, or isolated App Service plan tier. Deployment slots are live apps with their own host names, and app content and configuration elements can be swapped between 2 deployment slots, including the production slot. App Service can also host web apps natively on Linux for supported application stacks. It can also run custom Linux containers, also known as web app for containers. App Service on Linux supports a number of language-specific built-in images. Just deploy your code. Supported languages include Node.js, Java for both versions 8 and 11, PHP, Python, .NET Core, and Ruby. If the runtime your application requires is not supported in the built-in images, you can deploy it with a custom container, right? So if you wanted to do Go, for example. The languages and their supported versions are updated on a regular basis. You can retrieve the current list by using the following command in the Cloud shell. So I believe I have AZ working on here. Yes, I do. So it is AZ web app, list runtimes, list runtimes, OS type Linux. Okay, let's do this here. Oh, Go is supported already, apparently. So we've got .NET Core 6 and 7, several LTS versions of Node, the last 5 versions of Python, including Python 3.11, so that which was released just like the end of last year. Granted, that was only 3 days ago, but still. A couple of versions of PHP and Ruby for some reason, Java 8, 11, and 17, and then some Tomcat stuff, JBoss, which I believe is Java EE. I'm not sure about that, and then a couple of versions of Go. App Service on Linux does have some limitations. App Service on Linux is not supported on the shared pricing tier. You can't mix Windows and Linux apps in the same App Service plan. Historically, you could not mix Windows and Linux apps in the same resource group. However, all resource groups created on or after January 21, 2021 do support the scenario. Support for resource groups created before January 21, 2021 will be rolled out across Azure regions, including national cloud regions soon. Okay. The Azure portal shows only features that currently work for Linux apps. As features are enabled, they're activated on the portal. All right, app service plans. In app service, an app, whether it be a web app, API app, or a mobile app, will always run in an app service plan, which defines a set of compute resources for a web app to run. One or more apps can be configured to run on the same computing resources, which means that they're going to run in the same app service plan. And in addition, Azure Functions has the option of running in an app service plan. And we'll get to Azure Functions later on in the different module, or actually it's a different learning path. When you create an app service plan for a certain region, for example, West Europe, a set of compute resources is created for that plan in that region. And whatever apps you put into this app service plan run on these compute resources as defined by your app service plan. So each app service plan defines a region, the number of VM instances, the size of the VM instances, and the pricing tier. Now, the pricing tier of an app service plan determines what app service features you get, and I hear thunder, how much you pay for the plan. There are a few categories of pricing tiers. So the shared compute, there's free and share, and this shares a resource of pools of your apps with the apps of other customers. And these tiers allocate CPU quotas to each app that run on the shared resources, and you can't scale them out. Now, then you have dedicated compute, which are all these premium tiers, and they run on Azure. These run on dedicated Azure virtual machines. Only apps in the same app service plan share the same compute resources, and the higher the tier, the more VM instances are available for you to scale out. Isolated. Now, this tier runs on dedicated VMs on dedicated Azure virtual networks. So it provides network isolation on top of the compute isolation and has the maximum scale out. And then consumption, this tier is only available to function apps. It scales the functions dynamically depending on the workload. Okay. Now there's a note here. It says that these free and shared hosting plans are base tiers that run on the same Azure virtual machines as other app service apps. Some apps might belong to other customers. These tiers are intended only to be used for development and testing purposes. All right. In the free and shared tiers, an app receives CPU minutes on a shared VM instance and can't scale out. The other tiers, an app runs and scales rather as follows. An app runs on all the VM instances configured in the app service plan. If multiple apps are in the same app service plan, they will all share the same VM instances. If you have multiple deployment slots for an app, all deployment slots also run on the same VM instances. And if you enable diagnostic logs, perform backups, or run web jobs, they also use CPU cycles and memory on these VM instances. In this way, the app service plan is the scale unit of the app service apps. If the plan is configured to run 5 VM instances, then all apps in the plan run on all 5 instances. If the app is configured for auto scaling, then all apps in the plan are scaled up together based on the auto scaling settings. Okay. Your app service plan can be scaled up and down at any time. It's as simple as changing the pricing tier of the plan. If your app is in the same app service plan with other apps, you may want to improve the app's performance by isolating the compute resources, and you can do that by moving the app into a separate app service plan. You could potentially save money by putting multiple apps into one service plan. However, since all apps in the same app service plan share the same compute resources, you need to understand the capacity of the existing app service plan and the expected load for the new app. Isolate your app into a new service plan when the app is resource intensive. You want to scale the app independently from the other apps, and the app needs to be the app needs a resource in a different geographical location region. This way, you can allocate a new set of resources for your app and gain greater control of your apps. All right, let's see here. Every deployment team has unique requirements that can make implementing uh, de- an efficient deployment pipeline rather difficult on any cloud service. And Azure and App Service supports both automated and manual deployment. Automated deployment, also called continuous deployment, is a process used to push out new features and bug fixes in a fast and repetitive pattern with minimal impact on end users. Azure supports automated deployment directly from several sources, and the following options are available. So you can push your code to Azure DevOps, build your code in the cloud, run tests, generate a release from the code, and finally push your code to an Azure web app. Azure also supports automated deployment directly from GitHub. When you connect your GitHub repository to Azure for automated deployment, any changes you push to your production branch on GitHub will be automatically deployed for you. And then Bitbucket, with its similarities to GitHub, you can configure an automated deployment with Bitbucket as well. And let's see here, looking at the radar update. Um, it's in the city, but still has a ways to go. It still has a ways to go before it gets to me. All right, so let's see here. There are a few options that you can use to manually push your code to Azure. So you could use Git. There's a each web app has a Git URL that you can add as a remote repository, and pushing to the remote repository will deploy your app. And then the CLI web app up is a feature of the AZ command line interface. I believe that the command line we just looked at, the command we just looked at, yeah, AZ web app for list run times. Unlike other deployment methods, it can create a new app service web app for you if you haven't already created one. You could send a zip of your application files, or you could use FTP. Whenever possible, use deployment slots when deploying a new production build. When using a standard app service plan tier or better, you can deploy your app to a staging environment and then swap your staging and production slots. And the swap operation warms up the necessary worker instances to match your production size, and thus it eliminates downtime. Azure App Service provides built-in authentication and authorization support, so you can sign in users and access data by writing minimal or no code in your web app API and mobile backend, and also for Azure Functions. Now, you're not required to use App Service for authentication and authorization. Many frameworks are bundled with security features, and you can use them if you like. If you need more flexibility than App Service provides, you can also write your own utilities. There's more thunder. But built-in authentication feature for App Service and Azure Functions can save you a lot of time and effort by providing out-of-the-box authentication with federated identity providers, allowing you to focus on the rest of your application. Azure App Service allows you to integrate a variety of auth capabilities into your web app or API without implementing them yourself, and it's built directly into the platform and doesn't require any particular language SDK, security expertise, or even any code to utilize. And you can integrate with multiple login providers such as Azure, Active Directory, Facebook, Google, and Twitter, but not GitHub. Interesting. Hmm. App Service uses federated identity, in which a third-party identity provider manages the user identities and authentication flow for you. And again, here are the ones that are available. When you enable authentication and authorization with one of these providers, its sign-in endpoint is available for user authentication and for validation of the authentication tokens from the provider, and you can provide your users with any number of these sign-in options. The authentication and authorization module runs in the same sandbox as your application code, and when it's enabled, every incoming HTTP request passes through it before being handled by your application code. This module handles several things for your app. It authenticates users with the specified provider, validates, stores, and refreshes tokens, manages authenticated sessions, and injects identity information into request headers. The module runs separately from your application code and is configured using app settings. No SDKs, specific languages, or changes to your application code are needed. Now, here's another note. In Linux and containers, the authentication and authorization module runs in a separate container isolated from your application code because it does not run in process. No direct integration with a specific language framework is possible. Okay. The authentication flow is the same for all providers, but differs depending on whether you want to sign in with the provider's SDK. So without a provider SDK, the application delegates federated sign into app service, and this is typically the case of browser apps, which can present the provider's login page to the user. The server code manages the sign-in process, which is also called server-directed flow or server flow. If you have a provider SDK, then the application signs users into the provider manually and then submits the authentication token to app service for validation. And this is typically the case of browserless apps, which can't present the provider sign-in page to the user. The application code manages the sign-in process, so it is called client-directed flow or client flow. This applies to REST APIs, Azure Functions, JavaScript browser clients, and native mobile apps that sign users in using the provider's SDK. So the table below shows the steps. So to sign in the user without a provider SDK, it's going to redirect the client to a particular URL. With this provider SDK, client code signs user directly in with provider's SDK and receives an authentication token. After authentication is done, they're redirected to a callback URL. And then the client, but with its SDK, the client code posts a token from the provider to this URL for validation. To establish an authenticated session, app service uh, adds a cookie to the response, and without or with a provider SDK, the app service returns its own authentication token to the client code. And to serve authenticated content, the client includes the authentication cookie in subsequent requests that are handled by the browser. Otherwise, the client code presents the authentication token in a header. For client browsers, app service can automatically detect all unauthenticated users to a particular URL, and then you can also present users with one or more links to sign into your app using the provider of choice. All right. In the Azure portal, you can configure the app service with a number of behaviors when an incoming request is not authenticated. To allow, you can either allow those requests, and this option defers authorization of unauthenticated traffic to your application code. App Service also passes the authentication information in the HTTP headers, and this option provides more flexibility in handling anonymous requests. It lets you present multiple sign-in providers to your users. Okay. If you require authentication, then this option will reject any unauthenticated traffic. And this rejection can be a redirect action to one of the configured identity providers. And in these cases, a browser client is redirected to this particular login for the provider you choose. If the anonymous request comes from a native mobile app, the returned response is a 401, and you can configure the rejection to be a 401 or a 403 for all requests. Let's see, restricting access in this way applies to all calls to your app, which may not be desirable for apps wanting a publicly available homepage, as in many single page applications. Okay. By default, apps hosted in the app service are accessible directly through the internet and can reach only internet hosted endpoints. But for many applications, you need to control the inbound and outbound network traffic. Now, there are two main deployment types for the Azure App Service. The multi-tenant public service hosts app service plans in all of these in the free up to the premium SKUs. And there's also the single tenant app service environment that hosts isolated SKU app service plans directly in your Azure Virtual Network. Okay. App service is a distributed system. The roles that handle incoming HTTP or HTTP requests are called front ends. The roles that host the customer workload are called workers. Okay. All the roles in an app service deployment exist in a multi-tenant network. Because there are many different customers in the same app service scale unit, you can't connect the app service network directly to your network. All the roles because there are many different customers in the app service scale unit, you can't connect. Okay. Instead of connecting the network, you need features to handle the various aspects of application communication. The features that handle requests to your app can't be used to solve problems. The features that handle requests to your apps can't be used to solve problems when you're making calls from your app. Likewise, the features that solve problems for calls from your app can't be used to solve problems to your app. Okay, networking is definitely my weak point. So let's see here. Inbound features, access restrictions. Hmm. Okay. You can mix the features to solve your problems with a few exceptions. The following inbound use cases are examples of how to use the app service networking features to control traffic inbound to your app. Okay, so inbound use case. Support IP-based SSL needs for your app. Okay. This isn't a one-to-one. This is just a list of features. That should be a table, or should it? Okay, I don't know. Okay, so support unshared dedicated inbound address for your app, and restrict access to your app from a set of well-defined addresses. Okay. App service scale units support many customers in each deployment. The free and shared SKU plans host customer workloads on multi-tenant workers. The basic and higher plans host customer workloads that are dedicated to only one app service plan. If you have a standard app service plan, all the apps in that plan will run on the same worker. If you scale out the worker, all the apps in that service plan will be replicated on a new worker for each instance in your app service plan. Okay. The worker VMs are broken down in large part by the app service plans. Okay, the free through premium all use the same worker type, and then the premium V2 and V3 use different worker types, or VM types rather. When you change the VM family, you get a different set of outbound addresses. If you scale from standard to premium V2, your addresses will change. If you scale from premium V2 to premium V3, your addresses will change. In some older scale units, both the inbound and outbound addresses will change when you scale from standard to premium V2. It looks like here it just says the outbound addresses change no matter what, if I understand that correctly. There are a number of addresses that are used for outbound calls. The outbound addresses used by your app for making outbound calls are listed in the properties for your app, and these addresses are shared by all the apps running on the same worker VM family in the app service deployment. If you want to see all the addresses that your app might use in a scale unit, there's a property called possible outbound IP addresses that will list them. All right. Finding the outbound IP addresses currently used by your app in the Azure portal, you can click the properties of in your app's left-hand navigation, or you can get them from the Cloud Shell. So let's see here. I don't have anything set up right now, so but you would have this show, and there's that property that I mentioned above called possible Actually, it's just saying outbound IP addresses, not possible outbound IP addresses. Oh, these are the one. Okay, okay. These are the ones that are assigned, and these are the ones that are possible. Okay. All right. So next, we're going to create a web app, and we're going. Oh, cool. We're going to get a. We're going to get a sandbox, so I don't have to. So I don't have to set up Visual Studio Code. Needs to your permission. Yeah, that's fine. Okay, here we go. Now, didn't ask me for that last night. So it's going to create a resource group, and it'll create select a region from one of the following. Oh, okay, okay. So when we create the resources over here, we can only use these 10 regions. Use East US or Central US, be closer to me. Creating a storage account, file share, and it is done. Okay, now these you get 4 hours. Okay, hold it. Last night I was kind of shocked. I guess there's probably something about it trying to prevent abuse. I'm sure that's the reason why. But anyway, let's keep going. So in this exercise, you'll deploy a basic CM. Okay. In this in this exercise, you'll deploy a basic HTML plus CSS website to Azure App Service by using the Azure CLI web up AZ web app up command, and you'll update the code and redeploy it using the same command. Now that command makes it easy to create and update web apps, and when executed, it'll perform the following actions: create a default resource group if one isn't specified, create a default app service plan, create an app with a specified name, and zip deploy files to the current working directory from the current working directory to the web app. Okay, use the sandbox to download the sample app and set variables to make some of the commands easier to enter. All right, so first thing we need to do is make directory for HTML app and cd into that HTML app. All right, and then I'll just copy this one since there's a GitHub repo. Whoops, it's not going to let me do that. There we go. And now if I look, there's what I just created. Let's take a look actually here. Let's take a look at what the code is here real quick. Index. I thought there was a way. Hmm. Okay, I thought there was a way that you could actually preview it, but at any rate, seems to me there used to be, but okay, so set variables to hold the resource group and app names by running the following commands. Okay, so well, let's see here. AZ group list query. No idea what this. Okay, so this is a resource group in West US that has this name. Okay, so then if I do AZ group list query, okay, I guess that gets the that gets the list, and then this gets the ID property. Gets the ID property and assigns it to the name. Interesting. TSV. That is interesting. Okay, but at any rate, so resource group equals the output of this command. Then if I echo resource group, actually, hang on, no, I need to do this, don't I? Oh, there we go. Forgot the, and then app name. So if I say echo random, can I do this? That's not in there. Oh, okay. So app name equals AZ-204 app AZ. Thank you for nothing. Come on, app random. Okay, so app name is now going to be, oh, I'm sorry, echo app name. There we go. Okay. Create Z web app. Okay, so CD into that directory, AZ web app up -G, then the resource group, then the app name, and then HTML. I guess it just says make a static HTML web app. So now the app does not exist. So it's creating the service plan, the resource group. Remember, it said that would create a resource group if one isn't specified, but we specified one. Then it created the default app service plan, and it's creating the app with the name. And now it's should be zipping up the files and shipping them off. And I'll look at the radar in the meantime. There's actually some red building. Just that you may go north of me. I don't know. All right, here we go. Starting the zip deployment. Okay, and looks like it worked. Right here. So if we navigate to this site here, may take a few minutes before it's actually finished deploying. There we go. There's what we just deployed. Okay. So in a Cloud Shell type code index.html. Ooh, and it opens up an editor, a mini Visual Studio Code here. And the H1 heading tag. Where is the H1 heading tag? Right here. Okay, so we'll change it to app service. We'll just get rid of this. No. Hello world. Okay, so Control S, Control Q. And then we can rerun that same command. And now it's saying that it already exists, so it will deploy contents to the existing app. And now that's finished. This should be changed if I refresh this. There we go. All right. So that was pretty easy. Okay, so next we'll do a knowledge check. All right, which of the following, I think that was dedicated, supports only function apps? Which of the following network features can be used to assign, can be used to control outbound? I don't remember that, but I think it was this. Oh man, it's that thing. I got both of those wrong. So that's correct. That's weird. It hybrid. It says supposed to be hybrid connections, but he gave me the points anyway. Okay, but at any rate, consumption is available only to the function apps, and the hybrid connections for the outbound network feature. Okay. All right. At any rate, let's see here. So in this module, learned how to describe app service key components and value, app service manager's authentication, the inbound and outbound control. I want to go back and look at that again here because the networking features. Okay, yeah, hybrid connections are networking features. Okay, okay, and then deploy using the CLI commands. Okay, I'm going to take a little bit of a break. I will be right back. Okay, so let's see here. I don't know how far I'll make it through this one, because the storm is getting close. So I don't know how far I'll make it through this one, but we'll see what happens. All right, so this one is going to be configuring web app settings. So in app service, app settings are variables passed as environment variables to the application code. And after completing this module, you'll be able to create application settings that are bound to deployment slots. Explain the options. They didn't ask anything about deployment slots in the last knowledge check. I was surprised. Explain the options for installing SSL and TLS certificates. Enable diagnostic logging for your app to aid in monitoring and debugging, and create virtual app directory mappings. All right, configuring application settings. They're variables that are passed as environment variables to the application code for Linux apps, and custom containers. App service passes app settings to the container using the double dash env flag to set environment variables in the container. Application settings can be accessed by navigating to your app's management page and selecting configuration application settings. That's going to be in the portal. For ASP.NET and ASP.NET Core developers, app settings and app service are like setting them in app settings in the web configuration or app settings.json, but the values in app service override the ones in web config or app settings.json. Okay. You can keep development settings, for example, local MySQL password in web configure app settings, but production secrets in the app service. Okay. The same code uses your development settings when you debug locally, but it uses your production secrets when deployed to Azure. Okay, I see what's going on. Always encrypted was stored encrypted at rest. To add a new app setting, click New Application Setting, which is going to be right here. And if you're using deployment slots, you can specify if your setting is swappable or not. In the dialog, you can stick the setting to the current slot. To edit the setting, click the Edit button on the right side. When finished, click Update. Don't forget to click Save back in the configuration page. Default or custom Linux container, any nested JSON key structure in the app setting name like this needs to be configured in app settings as with a double underscore. So in other words, that should be replaced by a double underscore. Okay. To add or edit app settings in bulk, click the Advanced Edit button, and when finished, click Update, and you have this JSON schema here. ASP.NET and ASP.NET Core, the values are set in the app service. Override the ones in web config. For other language stacks, it's better to use app settings instead because connection strings require special formatting in the variable keys in order to access the values. And connection strings are always encrypted when stored. There's one case in where you may want to use connection strings instead of app settings for non-.NET languages. Certain Azure database types are backed up along with the app only if you configure the connection string for the database in your app service app. Okay. Adding and editing connection strings follow the same principles as other app settings, and they can also be tied to deployment slots. And here's an example of using bulk, of editing connection strings in bulk. In the configuration general section, you can configure some common settings for your app. Some settings require you to scale up to higher pricing tiers. Below is a list of the currently available settings, so the stack settings. And this is the software stack, including the language and SDK versions. For Linux apps and custom containers, you can also set an optional startup command or file. I've done that, but it wasn't okay. At any rate, um, for platforms, the bitness. I have not ever heard that. Huh. I would call that the bit width, I guess. But however, 32 or 64. If you want to use WebSockets, always on, which is keep the app loaded even when there's no traffic. By default, always on is not enabled, and the app is unloaded after 20 minutes without any incoming requests. Now, it's required for continuous web jobs or web jobs that are triggered by cron expression. Managed pipeline version, that's for IIS. HTTP version, ARRF. Whoa! I think the storms are here. Dang. In a multi-instance deployment, ensure that the client is routed to the same instance for the life of the session. You can set this option off for stateless applications. Okay, I don't know what ARR is. Debugging. Enable remote debugging for ASP.NET, ASP.NET Core, or Node.js apps. This option turns off automatically after 48 hours. I'm sure it's a security thing. Incoming client certificates require client certificates in mutual authentication. TLS mutual authentication is used to restrict your app to. Okay. Okay, configure path mappings. In the configuration path mapping section, you can configure handling. Just a second here. All right. So in the configuration path mapping section, you can configure handler mappings and virtual application directory mappings. The path mappings page will display different options based on the OS type. For Windows apps, you can customize the IIS handler mappings and virtual applications and directories. Okay, handler mapping. I'm probably not going to use Windows apps. I'll probably use I'll use Linux and containers, but we'll go through them real quick. Handler mappings let you add custom script processors to handle requests for specific file extensions. To add a custom handler, select new handler, configure the handler as follows. The extension is going to be the file extension you want to handle. The script processor is the absolute path of the script processor. Requested files that match the file extension are processed by the script processor. Okay. And use this one for your app's root directory. Arguments are optional command line arguments to the script processor. Each app has a default root path mapped to the root directory where your code is deployed by default. If your app is in a different folder or if your repository has more than one application, you can either add virtual applications and directories. And you can configure virtual applications and directories by specifying each virtual directory and its corresponding physical path relative to the website root. To mark a virtual directory as a web application, clear the directory checkbox. Okay, now you can add custom storage for your containerized app. Containerized apps include all Linux apps and also the Windows and Linux custom containers running on app service. Click New Storage Mount and configure your custom storage as follows. Name, configuration options, the storage account, the storage type. Windows container apps can only support Azure files. The storage container, file share name, access key, and the mount path. Okay, this will make more sense when we get into it, but there are built-in diagnostics to assist with debugging an app service app, and you're going to learn how to enable diagnostic logging and add instrumentation to your application, as well as how to access the information logged by Azure. The table below shows the type of logging, the platform supported, and where the logs can be stored and located for accessing the information. All right, so application logging is available on Windows and Linux, and looks like the logs are stored in either app service file system or Azure storage blogs. And this is just standard logging, and you can give them each a category. Okay, web server logging is Windows only. Detailed error logging is Windows only. Failed request tracing is Windows only. Deployment logging is Windows and Linux that's stored in the app service file system, and it helps determine why deployment failed. Happens automatically, and there are no configurable settings for deployment logging. Okay. To enable application logging for Windows apps, navigate to your app and select App Service Logs. Select On for application logging, file system, or blob, or both. The file system is for temporary debugging purposes only and turns itself after 12 hours, but you can use blob for long-term logging, and you're going to have a blob storage container. Can also set the level of the details. Set here for the logs, and then of course you have to click save. For Linux and containers in the app service logs, set the application logging option to file system. Specify a quota and number of days the log should be retained rather, and then save. For web server logging, which I believe, yes, a web server logging, select storage or file system. Again, the retention period, click save. And in your application code, you use the usual logging facilities to send messages to application logs. And for example, ASP.NET application system diagnostic trace, as shown here. Okay. Let's see here. Before you run stream logs in real time, enable the log type that you want. Any information written to files ending in txt, log, or htm that are stored in the log files directory will be streamed by the app service. Let's see here. Some types of logging buffer write to the log file, which can result in an out of order events. For example, an application log entry that occurs when a user visits a page may be displayed in the stream before the corresponding HTTP. Okay. So you can stream to the Azure portal, or you can stream using the Azure CLI, and that's in the Cloud Shell, or you can use the CLI on your local console. That would be like in Visual Studio Code. If you configure Azure Storage blobs, you need a client tool that works with Azure Storage. If you're in the app service file, you can download a zip file in the browser at these URLs. And the zip file contains console output logs for both the Docker host and Docker containers. Okay, for a scaled out app, the zip file contains one set of logs for each instance, and file system these log files are contained. Okay, well, I think that's going to be it for me for tonight. Um, yeah, this is it's getting closer. The orange has gone north of me, but there's a lot there's something coming. So I think I'm going to go ahead and sign off of here. Real quick, I do want to take a look at what's coming up. This one actually does not have any exercises, which is kind of interesting. Let's see what's in this one. Scaling an app. There's no, oh dear. Huh, there don't seem to be any exercises in these. Hmm. Well, let's check something real quick here. Because I do have some books about this. Let's see here. There's an AZ-204 book. And it starts with, here we go, creating Azure Web Service apps. There's the code. Oh, what is this? Code in action videos. Oh, I did not know they had. So let's see here. There's only 12 of them. Oh, no, there's no, I don't know. Let me see here. 3 months ago. Is there like a playlist? Ah, there is. Okay, at any rate, I'm gonna, but hold on. That's like the exact same thing. That's the exact same thing. But this shows you how to use this shows you how to use the portal. Okay, I'm I might take a little bit of a different approach, because this is just you read through this and then answer, you know, 2 or 3 questions. I mean, it's free, so and it says this learning path helps prepare you. So you probably need to supplement that with something. Okay, I'm going to get out of here and go see what the weather's doing.